Hello, welcome to lecture 10. Today I'm going to talk about polynomials. This is mathematics for class 10, chapter 2, based on NCERT syllabus. My name is Sangam Banerjee and my details are given below. Here again I would like to request students to go to my class 9 lectures. This is lecture number 11 where I have discussed polynomials, and this lecture will help in understanding the present lecture much better. So again I have taken this from the class 9 lecture. I have just cut and pasted here. So what is polynomial? So polynomial is a mathematical expression, something like this. Okay, 2x square minus 3x plus 4. This is a polynomial, and I will tell you what order, what degree and all in the next few slides. So apart from variable, this x is a variable. Apart from variable, it has some constant, this 4, 3, 2. These are the coefficients, and this is a constant. So it involves operation of addition or subtraction, multiplication, and non-negative integer exponent. So this is an exponent here, but no divisible by variables, but there is no divisible by any other variables. So this is here only in the numerator, there is no denominator, and it has a finite terms and not an infinite number of terms. So here there are 3 terms are there. So 2, 3, these are the 2, 3 are constant coefficient, 4 simply constant. There is a minus and plus, this is subtraction and addition operation, and this x is a variable. This is another equation. Here you have 2 variable x and y. So x and y are the variables. In this case only there were 1 variable, and this 2 and 3 by 2 are the coefficients, and 7 is again simply a constant. And this is linear where x to the power 1. So this has a power 1 here, and it's called degree 1. And when you have a quadratic, this variable x, there is a square here, x to the power 2. So this is of degree 2. This is a cubic, x to the power 3, then x square followed. These are the coefficients and these are constant. So this is of degree 3. Then you have quartic, x to the power 4. So depending on the power, you have this degree 1, degree 2, degree 3 and degree 4. And ABC are the rational numbers, and it can be from minus n to n. Monomial means only one term. 2x, this is a monomial, or some constant here is only a single term. 3xy, this is also monomial. This is also monomial. Binomials means 2 term will be there. This is term 1, term 2. So in each case you see there are 2 terms. This is 3xy by 2. This is 1 term plus x. These also 2 terms, this term and this. Trinomial means there will be 3 terms. This is 1 term, second term and third terms. And then you have something called zero polynomial. Any real number r, like 6, square root 2, any real number, or pi, 0, they are constant term. And degree of zero polynomial is not defined. Okay, this is, you don't have a degree for this. This is a constant. So only degrees means power 1, degree 1, x to the power 2, degree 2. And single term monomial, 2 terms binomial, 3 terms trinomial. So please go through my earlier lectures. Now we will discuss division of polynomial. That is, this polynomial is divided by this polynomial. This is a linear polynomial and this is a quadratic polynomial. So we do this division, which we have discussed in detail in class 9. So I will go very quickly. So you have here 3x square and this is x plus 1. So I have to delete this 3x square. So what should I multiply x? I should multiply x with 3x to get 3x. So if I subtract it, I can cancel it. So then, but this one is remaining. So 3x into 1 is 3x here. And now when you subtract it, this cancels and x minus x is minus 2x. And this minus 1 I bring it down. And now what I have to multiply x so that I get minus 2x. So I multiply x with minus 2. So I will get minus 2x. And then this one is remaining. So minus 2 into 1 is minus 2. So now I subtract this, but minus into minus becomes plus. So plus 2x minus 2x cancel. And again minus into minus is plus. So 2 minus 1 is 1. So I have a remainder. So what does it mean? And these are the factors x plus 1 and 3x minus 2, but you have one remainder. So for x equal to minus 1, you have one remainder, because x, if it is minus 1 plus 1, 0. So you have only the remainder. So px, that is p of minus 1 will be 1. And similarly p of, this is x minus 3x minus 3 by 2, that is x is equal to 2 by 3. So for x is equal to 2 by 3, also p of 2 by 3 will be 1. So here I have shown here that x plus 1 x equal to minus 1. So I substitute here, I get remainder 1. And similarly at x is equal to 2 by 3, and I substitute in this x or this dividend, I get again remainder 1. So if Rx is 0, then only we say that Gx is a factor of Px. This divisor is a factor. Otherwise it's not a factor. Please go through my class 9 lecture where I have explained it slowly and in more detail. So what is remainder theorem? If Px is divided by x minus a sum with remainder r, then P of a equal to r, as I explained it earlier. So let us prove it. We had earlier proved for a particular case. Now let us prove it for a general case. This Px is your g of x into into qx plus r of x, where g of x is x minus a. Okay, this is a divisor. So because x minus a is polynomial 1, therefore rx should be degree less than 1, that is 0. Okay, so this should be constant because this divisor is of polynomial 1. So you write p of a, that is x is equal to a minus a is 0. So you have this quantity goes to 0. So you have pa equal to r. This is what you have. And we saw with a particular example in our previous slide. Find the remainder when x to the power 4 plus x cube minus 2x square plus x plus 1 is divided by x minus 1. So that means what is the remainder? So how do you find the remainder? Whether it is 0, you substitute this x minus 1. So for x is equal to 1, that is p of 1. Now you substitute here and you will get 2. So the remainder is 2. So x minus 1 is not a factor of this equation. Okay, because you have a remainder 2 here. So is qt, this is 1, is it a multiple of 2t plus 1? Means is it a factor, that is there is no remainder? So I will not go into detail, just freeze it and see it, and I have explained it in my earlier. Just substitute it, 2t plus 1, that means t equal to minus half. So q of minus half is 0. So it is a factor. I will go a bit quickly because this was all dealt in class 9 lecture. Factorization of polynomial. So factorization of a quadratic trinomial by middle term splitting. Now, since this is a quadratic, you will have two solutions, but if it's a cubic, then you have, 3 terms will be multiplied. So here I can write, see, this is one term. I will write, this is your quadratic. So I take two linear terms, px plus q and rx plus s. These are two linear terms. I multiply. I will get something like this, pr. This is p into r, x into x. Then you multiply this into this. Here it is. Multiply q times and you multiply this. So you get this. So by taking common factor, so I take a common factor here, this x. So x is common here. So this is ps plus qr. So I can write that a is equal to pr because ax square plus bx. B is ps plus qr and plus c is qs. So here we have splitted the middle term. This is by splitting method, that is b is equal to ps plus qr. Now if I take this quantity and take a product, then I find that the product of this and this is nothing but a into c, that is ps into qr I can write as pr into qs, because we have seen that multiplication is commutative as well as associative. So using those idea, you can write like this. So pr is a and qs is s. So this, if you take a product of this, you get ac. So how do I exploit this understanding? So factorize 6x square plus 17x plus 5. So I split this term. So I know that 6 into 5 is 30. 6 into 5 is 30. And 30 you can get either by 2 into 15 is 30. And also we know that 2 plus 15 is 17. That is a into c is equal to 30, which I have seen here. And you have here 17 middle term. So I write 2 plus 15, that gives you 17. Okay. Just freeze it and see it and see how I have explained in earlier class 9. So you know this, a factor of 30 is 1 into 30, then 2 into 15. So I select this because I want some of this to be middle term, that is 17, and then 3 into 10, that will not help me. 5 into 6, this will not. So only this is the one which will help. So I break this 17, split the term. Now I take common, 2x is common, and here 5 is common. 5 into 3 is 15x plus 5. So now 3x plus 1 is common, so I take it common, and 2x plus 5. So please go through my class 9 lecture where I have explained this much slowly and in a much simpler way. Okay, now factor theorem. It says if px is a polynomial of degree n greater than or equal to 1 and a is any real number, then x minus a is a factor of px if pa is 0, or vice versa. If pa is 0, then x minus a is a factor of px. So we know from remainder theorem that dividend is equal to divisor times quotient plus the remainder. So if PA is 0, okay, this is your remainder. So if PA is 0, that means there is no remainder. Then PX is simply x minus a times QA, and then we can say that x minus a is a factor of PX, okay, because there is no remainder. And if x minus a is a factor, okay, if x minus is a factor, then I know that this is PX, and I say that x minus a is a factor. This is your GX, some polynomial. Then P of a, that is at x equal to a, this becomes P of a becomes 0. Let us now derive the quadratic formula based on completing the square. So this is a quadratic equation and you can find the solution. So what I do is I divide each term this by a, this is b by a, c by a, I write it here, and this is 0, so it doesn't matter. So here I use the last term as middle term divided by 2 the whole square. The middle term is b by a divided by 2, that b by 2a square. So this I am adding it, and this I am leaving it as it is. But since I am adding this, I have to subtract also. So this minus sign can go to the right and it becomes plus sign here. And now I can take this also to the side here. So now I have x plus b by 2a the whole square. So if I expand this, I will get this thing here. Anyway, this I have taken it this side here. So this is x square plus 2 times x into b by a, 2 get will cancel. So you'll have b a into x, and then you have this b by 2a the whole square. So I simplify this further here. Just go through this algebra. So you get b square minus 4ac by 4a square. You have to do cross multiplication, which I have done it here. So now this is the square here. So I write x plus b by 2a is equal to square root of this square root of b square minus 4ac by 4a square. And this is plus or minus because square of plus into plus is plus, and square of minus, that is minus into minus, is also plus. So I do not know whether it should be minus or plus. So I write both of them, plus or minus. So this is plus or minus b square minus 4ac. So square root of 4 is 2. A square is a, so I write it separately. So now I bring this term b by 2a to right hand side, so x is equal to minus. So just go through the simple algebra, and I'm sure if you patiently go through it, you will understand. But this solution has some property. These solutions are called zeros. So sum of, see, there are two terms, plus and minus. So if you take alpha as minus b plus square root of b square minus 4c by 2a, and beta as minus b minus these two solution, and if you add them, so you can see very clearly this plus and minus, this term will get cancelled. So you will have 2 of minus b by 2a, that is minus b by a. So if you take the product of this zeros, this solution, this is your with plus sign. Say I call it m and this one as n. So m plus n into m minus n is m square minus n square. So what is m square? That is b square by 4a square. And if I square it, this square root will go. So I will have b square by 4a square. Okay. So since m square minus n square, so these two term will get cancelled. And then I have 4ac by 4a square. So 4 cancels, a here down is a square, so it will be c by a. Okay, just do it. I have done orally, and you should able to do it by writing. So let us solve the same problem, that is find x for 6x square plus 17x plus 5, which we had done it earlier by splitting method. This is taken from this class 9 lecture on polynomial. Plus, please go through it. I will not repeat it here. So this is your formula. Okay, so here interesting thing is that if b square minus 4ac is greater than 0, then you have two real root, and if it is equal to 0, then there is only one root, one real solution, because this is 0. Plus and minus have no meaning now. And if it is less than 0, then actually I will not explain you. This becomes a complex number, and this is beyond the scope of class 10. So this we will discuss in higher classes. So then you have no real solution, you have some complex solution. Okay, now let us understand the geometrical meaning of zeros of a polynomial. It says a real number k is a zero of a polynomial px if pk is equal to 0. So here if we take px as a linear polynomial, y is equal to 2x plus 3. Okay, this is your p of x. So at what value of x, y will be 0? So here y will be 0 for x is equal to minus 3 by 2. Here it is, y is equal to 0 for x. So this is a equation of a line, y is equal to 2x plus 3. Actually, we have discussed in class 9, this is a slope and this is a intercept. So at x equal to 0, okay, this term is 0, so y is equal to 3. So this is a y-intercept. So at x equal to 0, y is equal to 3. This we have discussed in greater detail in class 9 in coordinate geometry also. So for a linear polynomial ax plus b, a is not equal to 0, the graph of y is equal to ax plus b is a straight line which intersect the x, namely at minus b by a, this is the value of x, comma 0. So at y equal to 0, this is your x-axis, so it will be minus b by a, that is minus 3 by 2. Please go through class 9 lecture also. And here you have a quadratic equation, and for a quadratic equation, this is your quadratic equation. Okay, so for x, so you can see that for this y is equal to 0, for x is equal to 4 and x equal to minus 1. If you substitute here, you see for different x, y is 0 for -1, and y is 0 for x is equal to 4. So for this is a parabola, the x square is a quadratic equation, and for a quadratic polynomial ax square, this we know these are the two solutions. If you substitute this value of b, a and c, you will get y equal to 0 for these values of x. So here one can say that the zeros of the quadratic polynomial, this polynomial, where a is not equal to 0, are precisely the x coordinate of the point where the parabola representing y is equal to this polynomial intersect at x-axis. So these are the solution. It tells you the zeros of the quadratic where it intersects the x-axis. So 4 is one solution, x is equal to 4 and x is equal to -1. For those cases, y will be 0. Now if you have this parabola, y is equal to 2x squared plus 8x, and if you add one constant plus 6, this whole parabola will move by 6 units. And how do we know where it will intercept? For this equation I have written this is 2x is common, so 2x into x is 2x square, 2x into 4 is 8x. So for x is equal to 0 it will intercept, and for x is equal to -4, this quantity will become 0. So this quantity will become 0 for x equal to 0 and for x equal to -. So this is minus for this line, so it will intercept. So similarly you can find the quadratic equation solution, and you can, if you find the solution, you will find these two dot also. Just try it as an example. I think it is x equal to -1 and x equal to -3. Just try to solve this quadratic either by splitting method or by quadratic formula. Now if suppose this is also a parabola, so this has a minus, so this quadratic term is minus, so it behaves like this. For a positive, it behaves like curvature is going up, the curve is going to the positive side. So you know this x-axis is positive, this side is negative, y-axis here is positive, y-axis here is negative. See, again and again I am saying to go and see my class 9 lecture. All these things are being discussed in detail there also. And this parabola, you see there is no intercept, so it is not intersecting x-axis anywhere, so there is 0. So you can have 2 or you can have 0. So for parabola, either it will intersect in two places or it will not intersect. If it is translated up, then it will not intersect. So either 2 intercept, y is equal to 0 at plus x here and some other value of minus x, and if it is translated, there is no, it will not intercept x-axis. And you can shift this parabola. This is y equal to x square parabola, and if I write x -1, so it is shifted in the positive direction. That is, at x equal to 1, it is 0. So 1 minus 1 is 0. So y is equal to 0 at x equal to 1. And here, if you have, this is the upward, as I said, is plus or opens downward. Okay, this is minus, and so it will intercept here at x equal to 0, y is equal to 0 at x equal to 0, or at x is equal to 4. Here also this thing at x equal to 0 or x equal to for the downward. So by now you should know how to visualize this kind of a low degree polynomial like linear, quadratic, like a parabola. And for a given parabola, you have an axis of symmetry, then you have a vertex here, the turning point, you have a y-intercept, you have a x-intercept. These are the solutions. Okay, this at y equal to 0. What is x? So you have two solutions. You have one inversion. You have one y-intercept here. So for a given curve, y is equal to ax square plus bx plus c, you have, say, suppose this is, you have solution, this is the x-axis, you have one solution. We have solved the quadratic equation, and this is, so y equal to 0 for this, and this is plus or minus, negative side. So if I add this x1 and say this is your x2, then x1 plus x2, this will get cancelled, will be minus 2b by 2a, that is 2 will get cancelled, is minus b by a. So half of that, so this intercept, this line, this symmetrical thing, it will intercept x at minus b by 2a. Okay, half of this one, x1 plus x2 divided by 2, this plus this divided by 2. Think about it. And x1 into x2, as I had explained earlier, so this will be c by a, and here, since this is the turning point here, this minima, so this is x-axis is minus b by 2a. So if you substitute the value of this x here, you will get the value of pi. So this is the value of pi. Just please do it as a homework. Now y coordinate vertex, that is x is, as I said, minus b by 2a for y is equal to x. So here I have done it. So you need not do as a homework now. So here it is a, I have substitute here, x is equal to. So just go through it at least, and so you will get minus b square. This is 4 times c, 4 times a times c is 4ac. So this is minus is plus, so it is plus divided by 4a. So this is what it is. So this parabola, as I said, it can have two roots, or it can have one root, or if it's translated, then you have zero root. This is for this equation x plus 2, this plus 2 minus 2. Here it is x plus 2 the whole square, so only one root, and both the root is coinciding here. 2 points are coinciding, and this has no real zeros, but it has two imaginary zeros. So that we will not discuss here. These imaginary numbers are complex numbers. Now example, find a quadratic polynomial, the sum and the product of whose zeros are minus 3 and 2. Sum is minus 3 and product is 2. So that is, I have a quadratic equation. Alpha plus beta is minus 3. That is, as we have seen, that alpha plus beta is minus b by a, and alpha times beta is 2 given here. And we have seen that alpha into beta is c by a for this quadratic equation. So I have now two equation, two unknown. So it is very easy to solve. So if a is equal to 1, then b equal to, this is minus b minus, so b equal to 3. And if a is 1, c is equal to 2. So I can write this as a with 1, b with 3 here, ax square plus bx plus c, and c is equal to 2. You can multiply this whole with some constant also. Then you will have some coefficient in front of x square also. Because they are all equal to 0, I have said you can check that any other quadratic that fits this condition will be of the form of kx square plus 3x plus 2, where k is some real. The turning point of this parabola, if y is equal to x minus h the whole square plus k, so turning point is at h and k. So here it is h is 0, k is 0, so it is at 0 0. And here it is x is 3, so at 3, and then this translated to 8, y is 8, so h comma, so its turning point will be at 3 comma 8 from here. Okay, now cubic polynomial, that is y is equal to ax cube plus bx square plus cx plus d. Okay, so here it is to the power 3. In a quadratic you did not have this term, only you started from this term square. So for positive x and negative x, x square was always positive, but the parabola was facing upward or downward depended on this sign of this coefficient. Okay, if it is minus, the parabola was open downward, and if b is positive, then parabola was opened up. But here it is interesting that x cube positive is okay, fine, but if x is negative, then it will go towards the negative side. And if the coefficients are positive or negative, it will flip. But you see here, they will go only in the opposite. So if the curve goes in x-axis upward, in the negative, it will go. And if you change the sign, this negative thing may go up and this positive will go down. So here you see f of x is equal to x cube minus x. So I can simplify it as x times x square minus 1. So you will have three solutions for x equal to 0 and x square minus 1. That means x is equal to plus or minus 1. So plus 1. So you have three solutions. So here only one solution, because f of x is x cube, so you have only one solution here. And here it is x cube plus x, that is you have x into x square plus 1. So now you will have x square plus x at x is equal to 0, this function is 0, and at x square plus 1, so that means x square will be minus 1, and square root of minus 1 is a complex number, so we will not deal with. So it has only one solution. So for this equation, this is at x equal to 0. If I write it this way, it will shift by 2 in the x direction and then by 3 in the y direction. Freeze it and think about it. Now we will see some interesting properties of this. If this is your cubic equation, here a, b, c is 0, that is the linear term, b is this one, here I have written b, this c is 0, and d is 5. So here one thing is interesting, that if b square minus 3ac, b square is 0, 9, 3 square is 9, or minus 3 square is plus 9, and since c is here 0, there is no term, so this is 9, and if b square minus 3ac is not equal to 0, then you will have two turning points. If b square minus 3ac is 0, then you have 0 turning point. So these are the criteria. Here I have shown for this one, I have expanded it here. So b square minus 3ac I have put here. Just freeze it and see. So this is equal to 0. So this has 0 turning point. So we will put all this in one table. example to understand it better. So for a cubic polynomial, again like in the earlier case with zeros alpha, beta and gamma, we have alpha plus beta plus gamma is minus b by a, and this product is c by a, and alpha, beta, gamma is minus d by a. So I will not do this because this is too lengthy, and kindly do it as a homework. Now we discuss quadratic polynomial. So this is to the power 4. So we turn next to quadratic graph where an even wider variety of shape is possible. So you can have many turning points. In parabola you had only one turning point. In a cubic you had how many turning points? Two turning points. Here you have 1, 2, 3, three turning points, or it can be 1. So this is f of x is equal to x to the power 4, and this is, I am not going to solve all these, the solutions here. So you have 4 solutions because quadratic 1, 2, 3, 4. That is the maximum solution is 4, or all of them can coincide also. This is for x equal to 0. Okay, and this, if you have a parabola square at very small number, this x to the power 4 will be smaller than, so this is flat. Just try to plot at less than 1, you will see like 0.5 into 0.5 is 0.25, is much smaller, but 5 into 5 is 25. So less than 1 it will become more flatter. So kindly substitute some numbers and check it yourself. Okay, now let us revise a bit what we have done so far. Here I have tabulated, that is the type of polynomial and number of x-intercept and number of turning points. So this we have discussed earlier. So for a linear you will have one x-intercept, this is a linear, and since this is a linear function, it is a straight line. A straight line has no curvature, so it has 0 turning. But quadratic will have a curvature. Okay, so it will have one turning point, and how many times it will intercept? It can either, this is a curvature here, this quadratic parabola, it is not intercept, it is not touching the x-axis, so it has 0 intercept, or it can have one intercept, or if this parabola goes down it can have two. So it can have from 0 to 2 intercept and only one turning point. For cubic, this is your cubic function y is equal to x cube. For x is equal to 0 it will touch the x-axis. Okay, and this is for the positive x, and this y will change the direction when it is negative x. Okay, negative minus x to the power 3 will be negative, y will be negative, so it has to go to negative. This is also a cubic equation, x minus 1 into x plus 1. So here you see for x is equal to 0, you have y equal to 0. So one should know that along the x-axis y is always 0. Then only you say it is an x-axis. So for x is equal to plus 1, that is 1 minus 1 is 0. So y is equal to 0. So this is another solution. X is equal to plus 1. It will touch y equal to 0. It will touch the x-axis. And for x equal to minus 1, this is minus 1 plus 1 is 0. So again you will have for minus 1 also y will be 0. So you have here 3 points at 3 intercepts. Okay, so it will be, cubic will be either 1, 3. Here you see this same function, it goes up, or it can touch here, this is a function x plus 2 into x minus 1 the whole square. So at x is equal to 1, this is 1, you have two solutions. So this is 2 and this is one more solution at x equal to minus. So at here all the three solutions coincide at x equal to 0. Here there are 3, and here you see there are 2 at x equal to plus 1 here, and this is at x equal to minus 2. So you will have 1 or 2 intercept, or here there is 3 intercept. And how many turning point it can have? It can have either 0, here there is no turning point, or it can have 2 turning point. If it is 1 turning point, then it's a parabola. But since it is a cubic, it has to come like this and go like this. So you'll have 1 and 2. So either 0 or 2 for cubic. And similarly for quadratic, this is your quadratic function. Here also you see I have shown here quadratic function. Here is 4x to the power 4 minus 6x square plus 2x, and here I have added 9 by 2, so it has shifted, the red one. So here it is no intercept, so 0 intercept. You can have 1 intercept also, this just simply touching it here, then it will 1 intercept, or you can have a 2 intercept, which you can see that this goes from here, this comes here, so here 1 intercept, so 2. Or if this just simply touches the x-axis, you have 3, or if it overshoots here like this here, so you have 1, 2, 3, 4. So it can have from 0 to 4. So for quadratic, how many number of turning points you will have? You will have minimum 1, okay, because it's like a parabola. Or it can have 3 turning point, but not 2. 2 is for the cubic, okay. It has to go 2. This is 1 turning point, 2 turn. But for quadratic, you will have 3. So here you can see that for even power of x, you have 0 intercept. Here is 0. This is also quadratic is also. And for odd power of x, you will have at least one x intercept. So maybe we'll discuss in some conjecture. So here also I have plotted some function. So x plus 2 the whole square. So at x equal to minus 2, you will have intercept, and also at x equal to 1. Okay, so this is a cubic, x square into x, and here this is a quadratic. You see x cube into x, here is x. So here at x equal to minus 2, you will have three solution coinciding, and at x is equal to plus 1. So if this is plus 1, 1 minus 1 is 0, the whole function is 0. And this is for the quintic, x plus 2 to the power 4 into x minus 1. Okay, so this is the higher term will be x to the power 4, and this x also. So the highest power will be x to the power 5. So this is quintic, and you see in quintic you have, we'll discuss this more in detail. Here at x equal to minus 2, you have 4 solution which is coinciding, and x equal to 1, that is 1 minus 1. So one solution at this x equal to 1. Okay, fx is equal to 0 for x equal to 1, and fx also is equal to 0 for x is equal to minus 2, but this is to the power 4, so all the 4 solutions are coinciding. By now I think it should be clear. So here you see I have plotted the quintic curve. Okay, and as I said, for the quintic you have how many number of turns? This is 1, 2, 3, 4. So for a graph, here I have written here, for a graph of polynomial degree n has at most n minus 1 turning. So if it is n x to the power 1, 1 minus 0 turning point. For a quadratic, at least 1 turning point. For cubic, that is x to the power 3, you will have 2 turning point. And for quartic, we saw you have 3 turning point, and here you have 1, 2, 3, 4 turning point. Okay. So here I have written, we can see that the graph of polynomial even degree has an odd number of turning point. Okay. While the graph of polynomial of odd degrees has an even number of turning. So please go back and see and verify this. Now let us present few conjectures based on this. That is, number 1, the graph of a polynomial of degree n has at most n x intercept. Power 1 will have 1 intercept. X to the power 2, that is quadratic, will have maximum 2 intercept. It can have 0 if you shift it. So please go through what we have discussed. The graph of a polynomial odd degree has at least 1 x intercept. So here you can have, for even number you can have 0 intercept, but if it is odd power, then definitely, as I mentioned, at positive x it will go in the positive y, and for negative x it will go to negative y side at very high value of x. This is for the odd degree. The graph of a polynomial degree n has at most n minus 1 point. We mentioned this earlier. The graph of the polynomial even degree has at least 1 turning point. So even degree means 2 is an even degree, will have at least 1 turning point. Even x to the power 4 at least will have 1 turning point, but not cubic. Cubic will have a no turning point also. Like x to the power 3, it has no turning point. So the graph of a polynomial axn plus this behave asymptotically like its leading term. So that is, when x is large approaching plus infinity or minus infinity, the fx has the same behavior approaching plus infinity or minus infinity as. So what it means, that this term will dictate what will be the behavior. Okay, if it is even power, this function will be positive, but if this coefficient is negative, it will flip it. So please go through what we have discussed. You will understand what. And just freeze this slide and read this again. This is the summary taken from a book, and we have covered mostly everything as shown here. Now I will do some exercises for the sake of completeness. The graph of y is equal to px is given in figure this 2.10 below for some polynomial. Find the number of zeros. So here there is no zeros. Here there is 1 zeros. Here there are 3 zeros. 1, 2, 3. So this is a cubic, if you remember. Okay, this is a parabola, 2 of them. Okay, this is your quadratic. Okay, like a W or inverted W. So you have 4 solutions, and here you have 1, 2, 3 solutions. Okay, for x, for y equal to 0, for this x, these are the solutions. This exercise 2.2, find the zeros of the following quadratic polynomial. So that you use this formula and verify the relationship between zeros and the coefficients, and see whether if you add this solution you get minus b by a, or if you take a product of this 0 zeros or the solutions, then see whether it is C by A for one particular. Okay, that is 8 by 1 minus 8. So if you take the solution and take a product, you should get minus 8. So I am not going to do because it is algebra. You should practice. Okay, because there is no point listening if you don't practice it. And I will give the slight difficult ones. Maybe I will tell you. Find a quadratic polynomial each with a given number as the sum and the product of it. So you find the quadratic polynomial, and if sum and product are given, this is your sum and product respectively. So here I have taken for say this example. Randomly I have chosen it. Say sum is square root 2. So that is minus b by a. This is sum. Minus b by a is okay. Square root of 2 by 1 is square root 2. Okay. And c by a, this is a product, is 1 by 3 by 1 I have. So here a equal to 1 and b equal to minus root 2. And here c equal to 1 by 3. So I have now a, b, c. So this is my equation. Ax square minus, this is minus root 2x plus 1 by 3. So this is the your polynomial, quadratic polynomial. So similarly for this say 0 and root 5. So minus b by a, this is sum is 0. So I take 0 by 1. And c by a is square root of 5 by 1. So if a is 1, then b is 0 and c is, your quadratic equation is x square. Okay, ax square, b is 0. So forget about bx, and c is plus root 5. So similarly these are all simple thing, and you should practice this. Now exercise 2.3 of your book. Divide the polynomial px by polynomial this gx. This is your dividend, this is your divisor, and find the quotient and remainder. So I will not do it. I have done several times. Okay, this is how you have to do it. Here I have shown for something here. So this is your dividend, this is your divisor, x square minus 2 you put here, this one you put, and try to subtract each of them. First 3x4 you remove, then 6x cube you remove from the remainder, then this 3x square will come, you remove 3x square, and similarly go on till you get 0. So check whether the first polynomial is a factor of the second polynomial by dividing the second polynomial by the first polynomial. So here it is, this is your second polynomial by first if you do it, and see whether the remainder is 0. So similar thing, if it is not 0, then this is not a factor. I will not do it. I hope you are understanding what I'm saying. Just take this as a dividend, this as a divisor, and if you do something like this, then if there is a remainder, then this polynomial is not a factor of this. Now exercise 3, that obtain all other zeros of this polynomial is a quadratic polynomial if two of its zeros are this. So if these are the root, so a plus b into a minus b, I can write as x square minus 5 by this. The square root will go. Okay, a plus b into a minus b is a square minus b square. So this is what I've done, and this is your dividend here. This thing is here, and if you divide it, you will get this quotient. And once you get this quotient, again you factorize it. So I'm not going to do this factorization. So you have here two factors, and another two you will get from here, from the quadratic. On dividing this dividend by polynomial, this divisor, the quotient and remainder were x minus 2 and minus 2x plus 4 is a find gx. So we know that this division algorithm, this is a dividend is quotient times this divisor plus rx. So I can write, you have been told to find what is gx. So gx is nothing but px minus rx times qx. So these are given here. So you please do little algebra and you will get this gx. Just freeze it and see it. Now exercise 5, give examples of polynomial px, gx, qx and rx which satisfy the division algorithm and degree of px is equal to degree of qx. So here I have taken some example, that 2x plus 4 divided by 2. So you see here degree of px, this is degree of px is linear, and this is also linear, the qx is also linear, and your degree of rx is 0. And so here degree of qx is equal to degree of rx. So degree of qx is equal to degree of rx. You see degree of qx here is x and degree of remainder is x. So I have taken like this example. So freeze this and go through this one. Okay, now exercise 2.4, which is optional, but anyway let us see what they have asked. Verify that the number given alongside the cubic polynomial below are their zeros. Also verify the relationship between the zeros and the coefficient in each case. So this is the zeros, half, comma 1. So if these are alpha, beta, gamma, you can substitute here and see whether you get this formula, or you can do as x minus half into x minus 1 into x plus 2 and see whether you get this. It's the same thing here. Since you have been given this, you can directly substitute here and see it. This may be easy to do it. Similarly do for this also. Second, find a a cubic polynomial with the sum of the product. So this is for the cubic sum, then sum of the product alpha into beta plus beta of its zeros taken two at a time, and the product of its zeros. This is product of alpha, beta, gamma. Are 2, this 2 minus 7, this is minus 7 and minus 14. So I can write 2 as 2 by 1. So A is 1, then B is minus 2. If A is 1, then C is minus 7, and if A is 1, D is 14. Okay, minus D, so D is 14. So I can write this cubic. So this is easy. Third, if the zeros of the polynomial are A minus B, comma A plus B, find A and B. So here I have done here that A minus B are the zeros of this. So I can write the sum of the zeros is alpha, beta, gamma is equal to 3. So here 3A, this plus B minus B cancel. So 3A is equal to 3. So A is equal to 1. So now this product alpha, beta, gamma, A minus B, these are the solutions. Okay, it is written here, this and this. And here the product of zeros, that is this times this times this alpha, beta, gamma is minus D by A. So this is A, B, C, D. D by A is minus, this is plus 1 divided by 1, and this is minus. So this is product of zeros is minus. So since A is 1, so 1 minus B into 1 plus B, this is 1. So A minus B into A plus B, I can write as A square minus B square. So A square is 1. This is minus B square. So this B square you put it here. So B square is equal to 2. So B is equal to plus or minus root. So A is 1. So we have found. This 2 is also very similar. I will not do here because the lecture will become too lengthy now. And so thank you and see you in next lecture.